Okay. Hi guys. So before we start, let me just make some introductions. So my name is Irina. I'm from Vincent. I work with our partners. I developed the Fuel plugin SDK.
And my name is Vincent. I'm a 6WIN CTO, and we work with Mirantis on some NFV deployments.
Okay. So before we start speaking about 6WIN specifically, let me just remind you about Fuel. So basically, Fuel is an open source deployment tool, as you know. And there is a way to plug some proprietary technologies into Fuel. So this can be done using Ansible, Puppet. You can just build your product into any stage you'd like to have it. So it's a very flexible thing to work with. So in addition to just saying what the Fuel plugins are, let me just remind you about the Fuel plugin SDK. So basically, the Fuel plugin SDK provides all the information on how to develop your plugin and how to build a CI/CD pipeline around it. It's kind of comfortable thing to use for new buys to Fuel and to OpenStack. So you can find more information in the OpenStack documentation center and in the OpenStack wiki. And now I'm passing the ball to Vincent to focus on 6WIN details.
Okay, thank you, Irina. So what we are going to show is a demo of NFV deployment. So first, let me present what are the target of this presentation. So for us, we are going to deploy a 6WIN virtual accelerator that will accelerate packet processing of the neutrons vSwitch. This deployment will be done using Mirantis Fuel. Then we will do some benchmarks and see how Linux is accelerated. And then using a NICs here, that I don't have here, so that's why we use a video, we'll check the latency and we'll check the throughput. So for that, we use a very simple topology with a Fuel master, a controller, and 2 compute nodes, and 2 networks, which are 2 10 gig networks. So you may be used with the Fuel web UI, so it's pretty comfortable to use. And by the way, we use Fuel for 2 reasons, because in 6WIN Lab we need to make easily some OpenStack development, some OpenStack test. So for that, Fuel has been very comfortable, and moreover, we need our customer to feel comfortable when they deploy some NFV environments. So right now, I don't know if Irina, you want to comment, or should I continue? Okay. So right now we are, let's say, doing the setup of the platform. So we define the Fuel project layout. So we let most of the default environments. So then we are going to set some few networking and hypervisor settings. So for instance, and yes, of course, we have to enable virtual accelerator. So since we are a Fuel plugin, it means that we have one more checkbox in the Fuel environment. Once you enable the checkbox, then we're going to deploy a DPDK application on the host. And the DPDK application is going to accelerate any packet processing out of IP table, Linux Bridge, and OVS. So here it is. So we enable the virtual accelerators version 1.4. We can do some fine-tuning if we want. So then we are good to go. Then we are going to define the networking schema, which is specific to the 6WIN labs in Paris. So there's some few cosmetics that you may get used to do when you have to deploy your networks, to define your management, your private networks. Some few layer 3, since we use some VXLAN, by the way, overlay. I don't know if you noticed that previously. Since we are not connected to the public network here, we use a private NTP server. And we should be almost good to go. Oh, yes, I forget. So then we'll give some roles. So 1 controller, as you could see, and then 2 compute nodes, which with virtual accelerator enabled on both controllers. So on each, we set up the role of the interfaces, which is same, just click and play. So you don't need to be an expert in settings, DevStack, or your Neutron or ML2 configurations. So we should be almost done with the role of the interfaces for different networks. Yes, so still the last compute nodes, Lion. And yes, should be good. So 9, we are going to check something very nice in Fuel environments. We have an automatic check, so it's going to check that the network is correct. Of course, it's recorded video, so it's going to be correct, no surprise. Then we are good to go, so we're going to deploy. So we have 2 options. Maybe we go to have a coffee break, because it may take an hour. Or here we did accelerate the video, and you will see, since the video, we're going to, in a couple of seconds to have the deployment done. So what is happening under the hood? I mean, Mirantis Fuel is installing all the packages over the Ubuntu 14.04 and is installing the 6Win Debian package on every compute node. And now we can connect over the horizon interfaces to spawn some virtual machines. So there's nothing specific to NFVi, in fact, right now. It really looks like OpenStack, and I'm not telling you that you have to do specific DPDK setting because of NFVi. So now we move to, let's say, the very interesting part, which is going to be, okay, what is going to be my performance? So we're going to use 2 VNF. So 6Win, we are a company selling many applications on top of DPDK, some VNFs that you can run in virtual machines, and some virtual switch accelerators that we can run on the host. So in this case, we did want to compare what would it mean for some OVS accelerations, or I could use some Linux bridge, I could use some combination of Linux bridge and OVS. In fact, it could even use some Calico Layer 3 network model if needed. I will push traffic from the XCI, and thanks to the XCI, I will be measuring the throughput and the latency. One thing I didn't show in the demo, maybe I don't know if you want to add, but we have deployed Grafana to do some monitoring. So do you want to explain how we did that?
Yeah, I can just add a few words to this. So we basically have this TechLite set of plugins which allow monitoring, alerting. So very useful thing to enable. So
that's it for the introduction of the benchmark. So now let's look at the details. So just some few version check, so you feel comfortable with it. So we have on Ubuntu 14.04 with a kernel 3.13. Okay, so we are set. So from it's a Mitaka release that we deployed with Fuel 9, 6Win Virtual Accelerator product version 1.4, and you have seen that maybe from the Fuel UI too. Now I'll do a pause here and look at the line 25. You have an ETH4 interface. You will see within a few minutes on this demo that ETH4 is a DPDK interface, but when I use IP-Link show, I still see the interface. If you scroll down on line 46, I have a tap interface. This tap interface is still a VS user, and you will see what's going on. So because I have tap interface, I can still use legacy tools like ETH tool. And as you know, when you use ETH tool-I, if it's a Linux interface, I will see an IGB interface. But here, because it's a DPDK interface, a DPMD, I see RT IGB PMD, which means that because I have a net device that feels like this system is still a Linux, even if DPDK is being used. And I have my tap interface. So tap interface same won't be a tune tap because that's the default kernel. It will be a data plane virtual interface that is used for fast packet processing through the VS user. And because I have net device, I can use any tools like ETH tool-K. I can, and you will see next, I can even do things like tcpdump. So I'll make a simple comment. If you ever try to deploy some OVS DPDK with OpenStack, when you have to debug your traffic, you are like that. Okay, where is my traffic? You don't see anything. You're fully blind. Here, I get my XCR traffic, Proto 61. I can run tcpdump on my tap interface, on my ETH4. I can do my IP route show. I can monitor the stats. It really feels like a Linux environment. So that was for the review of the deployed system thanks to Fuel. So now let's do some measurements. So remember, we had 2 compute nodes. So right now, thanks to Grafana, and we are going to check it with the XCR at the same time, we'll monitor the traffic. So we are pushing some traffic to the system. We are pushing about 20 gig. So, and it's supposed to be VXLAN, and we only get 5 gig of traffic. And 4 cores of Linux are busy to process the traffic. You can see that on the Linux CPU. So then I move on. It's pausing. Then, so okay, traffic keeps going. Then we will, the 4 Linux cores are busy. As you can see, there is no fast-path CPU which is being used because we didn't enable the 6-win virtual accelerator on this computer. So now, next is we have 1 Linux core which is fully busy. As you know, DPDK is pinned on some cores. We are still pushing 20 gig of traffic through the VNF, and the virtual switch sustains the 20 gig without any issues, with a single core processing the packet for the vSwitch. So we have the 20 gigs in, 20 gig out being processed. We have 4 times more performance. In fact, we could even go higher because we just add 2 10 gig ports, and only 1 core is being booked on the host side by the 6-win virtual accelerator. You could allocate 2, 4 cores if you want even to go higher. So now, next for NFV, there is something which is very important. It's not only throughput, it's about latency. If you deploy some Cloud Run applications, latency matters. If you deploy some transactional solution in a data center, latency matters. So if we compare the Linux, any kind of OVS, Linux bridge, the latency can be pretty high. We get about 112 microseconds. When we run it with the 6-win virtual accelerator, the same setting, no modification, same VXLAN setting, same security group, no modification, we go down to 9 microseconds. So it's about 12 times better latency compared to the legacy packet processing virtual switching without any modification, and you still keep all the nice Linux capability. So to make it short, the 6-win vision of packet processing is Linux provides a nice data model for networking. I mean, some IP tool, IP table tools, a BRCTL, OVS tools. We don't want to lose them. We just want to accelerate the packet processing. So that's what we do with the virtual accelerators. So we get higher performance, lowest latency, while we keep the Linux data model. And moreover, we are pleased to use a nice tool to deploy these OpenStack environments in an easy fashion, in a scalable manner. So I think I'm done. So I don't know if you want to add anything, Irina, or we jump to the question.
Feels like we're done.
Okay.
So thank you.